argument, not getting into it, but you can show that it's really a martingale actually, because it's equal to the stochastic enthalpy. Okay? You can show that it's a martingale. But martingale with respect to what probability measure? P martingale actually. So this V of t times, can you see where I'm heading? So this exponential times B of t is P martingale. And look at the lemma. So this is going to tell you that if and only if so if you have, if xt is Q martingale, then xt, exact h of t is a P martingale. So I can say that B of t is a Q martingale. So the second condition of Levy characterization theorem is satisfied. Okay? Second condition of Levy characterization theorem is satisfied, because that's what we need to show it. Now the only thing that remains is the quadratic variation. Okay? So for the quadratic variation, finally, by repeating this same argumentation, I'm just writing the final end result here, like this. Now consider this process. B square of t minus t exponential h of t. Okay? So in other words, take your B square and apply the Ito lemma on it and do your all calculations, and I'm just writing it in integral form actually. What we can show that this is equal to 0 to t 2 b of s plus w square of s minus s exponential h of s and dws. So can you see what's going on? So I'm applying Ito lemma on this. The same as I applied Ito lemma on exponential time beta, b of t, so I'm applying here, so I'm going to get this. Okay? And now, what does this shows? That this b square of t minus t is a Q martingale with the same argument. Can we say it? Okay? B square of t minus p of t is a Q martingale. And now finally, any b square of t can be written as b square of t minus t plus t. If b of t is Q martingale, what would be b square of t? So it would be a sub-martingale. So a sub-martingale is a martingale plus a predictable process. So you have this Doob-Meyer decomposition actually. And this Doob-Meyer decomposition, so what we can show with the Doob-Meyer decomposition, that if you take a square of a sub-martingale, it would be a martingale plus its quadratic variation actually. So the Doob-Meyer decomposition result, it's a bit different result, okay, than what we did in discrete time process, but we can show that the square of a sub-martingale is a martingale plus its quadratic variation actually. So what does this mean? This means that the quadratic variation of the process Bt must be t because of this decomposition actually. Okay? Because since this can be written as a martingale plus some function, so whatever this function is, this is the quadratic variation of b of t. Okay? So what you're going to say? You're going to say that so b of t has all three properties. It has quadratic variation t, it's a martingale with respect to the probability measure q, and it's 0 at 0. So the Levy characterization theorem is telling you that this b of t is a Brownian motion. See you in next class. Okay? I know there are